All right, so now we're going to take a look at the antiderivative as the area under some function and just the relationship that it has there. So if we sketch the region under f of x is equal to 2x plus 1, so just this line, to an arbitrary point x, so that point would just be x comma f of x, then we find the area under the curve expressed as an area function. We can do that just by setting it up as a trapezoid, right? So if we just fill this in, it's 1/2, and then b1, like the one side is 3, and then plus 2x plus 1, so that's this side of my trapezoid, and then x minus 1 is the bottom, right? Expanding this all out, we get an area function of x squared plus x minus 2. Now, if we take the derivative of that, so a prime of x, we get just 2x plus 1. All right, so yeah, so this just is our our original function f of x, right? So we can say, all right, then that means that a prime of x, the derivative of x, or of the area function, is just equal to f of x. And if that's true, right, if like the derivative of the area function is just equal to our original function, then we can say the area function must just be the antiderivative of f of x. So like usually capital F of x. And don't overthink this. Sometimes it can get a little bit complicated, but you're really just going like one way or the other, right? So this is just kind of like a bit of proof showing that, if we want to find the area function under some graph, what we have to do is we just have to take the antiderivative of our function. Okay, so this was really just an example of our area function being the antiderivative of our original function. But let's look at this as a proof. So this first part just is the statement from above, but here's the proof. So it says if we have a function f of x, so just imagine this picture, and we have an area function, so that's kind of the shaded area here, then we can think of the area of the shaded region as the area of x plus h. That would be like the area, like the whole thing, right? So from 0 to here, right, the whole thing, and then minus the area to x. So you just subtract that, and you're just left with this chunk here. Okay, so we can think of it in those terms. Now consider taking the derivative of the area function a of x using first principles. So we'd set that up like so, like we did in earlier units, right? But now it's with an area function, which is a little bit different, but just bear with me. And then if we notice that the area function can also be expressed as the area of a trapezoid, right? Like it's approximated that way. And we're going to take the limit of that. So it's going to be on a very, very small scale is what we're thinking, right? So it does work to think of it as a trapezoid. Then the area of a trapezoid is just this. But then we can also think of that area of a trapezoid in terms of f of x. So just back to our picture, we can think of f of x plus h. That's really, so here's x plus h. That's my height right there, right? So that's just the one height of my trapezoid. And then plus f of x, so that'd be my other side of my trapezoid. And then divided by 2, and then times h, where h is the bottom section of my trapezoid, right? Which is like the same as this h. Okay, so that just is the area of a trapezoid itself too. Okay, so now what we can do is we can replace our original area function with this, right? With what we just found. And now we see that the h's will cancel because that is the same h, right? That's the bottom of my trapezoid, and that was also the length of my like x plus h for my area function. So my h's cancel. Okay, so now as h approaches 0, so now we're able to throw 0 in for h, and we get f of x plus f of x, which is f of 2x, and then it's over 2, the 2's cancel. So we actually have a proof that the derivative of the area function is equal to the original function itself. Okay, so we can imply that the area function is the antiderivative of f of x. Okay, so in general here, the way this is going to work is that if we want to find the area, then what this says, the area is equal to the antiderivative of at B minus the antiderivative at A. That's just saying like the antiderivative of at this point minus the antiderivative at this point would be the area between those two values.